Okay, this little section right here, it's actually not that little. We're going to take a few days on it. Okay, it's a big old word that describes this stuff, and you've probably seen this word before. In Algebra 2, definitely. You might have seen a little bit of it in Algebra 1, probably not too much in geometry. Once in a while in my geometry class, they throw a problem in there where you have to do this stuff, but it's always kind of like a surprise. They don't give you a whole lot of that stuff, but definitely in Algebra 2. This is a huge topic in Algebra 2, and they're called quadratic equations. Does that sound at least familiar to you? Maybe you don't remember what it is, but do you remember hearing that word at all? Quadratic? Yes? No? Anybody? Respond, please. Yes, either in a negative or a positive would be good.
Yeah.
So yeah, you have. Good. I hear a few people saying yes, they at least recognize that word, quadratic equation. Well, here's the basic form for a quadratic equation. Today we're not going to get into it this heavy. Tomorrow we will, okay? But it looks like this. Watch. ax squared plus, do you remember this? bx plus c, constant, equals what?
Parabola?
Equals 0. Well, it is an equation for a parabola. We're not going to really do that in here. That was more of an Algebra 2 thing. But right now we're just going to learn how to solve these things. But today's going to be a lot easier. All right, but I just wanted to show you what the basic quadratic equation was. Do you remember doing the quadratic formula? You probably did that last year, didn't you? We're going to do that again this year. I'll just give you a little sneak preview. See if you remember it. We're not going to do this today. This is just, do you remember this? Negative b plus or minus. This is coming back to you yet?
Yeah. I remember
dreading it. So this is bad memories or good memories? Bad? Really? Yeah, I think, to tell you the truth, I think when we were doing quadratic, and you're going to see that in here as well, when you did quadratic equations, we're going to do this maybe in the second day, probably not tomorrow, maybe the next day after that. We're going to learn this thing, and you're going to like this thing. I believe you will. Most students do. Most students usually like seeing this, besides doing it another way that I'm going to show you how to do it tomorrow. Does that make any sense at all? Probably not. But I think a lot of students tend to like this quadratic. We call this the quadratic formula. This is the equation, and this is the formula. Well, how did I get the formula? Well, I'm not going to do that today, but guess what I did? See where it says x equals all this stuff? Guess what I did on this equation right here? I solved for what? For x. I just solved for x, okay? So when I solve for x, so if I have this thing right here, look at it. I got hardly any numbers at all, right? Got that little squared thing, that's it. Got all these letters, but I can actually do a process that we're going to learn tomorrow to get x by itself. All right, so that's just sneak preview stuff, right? We're not going to, oops, let me grab all of that. We're not going to really get into that today, but tomorrow and the day after, we'll probably hit some of that stuff. All right, so that's what a quadratic equation is. The a, b, and c represent numbers. Okay, you put numbers in there. So it could be like 3x squared plus 5x plus 7 equals 0. And then you could actually solve for x, and that's the kind of stuff we're doing. But we're going to start off really easy. Do you remember this? Let's start off like this. We talked about this not too long ago because we did square root of negative 1 and all that. But what if I had that, the square root of 36? If I just said, walked up to you on the street, tapped you on the shoulder, and said, what's the square root of 36? Then what would you tell me? You would say plus or minus? Good. Okay, most people would probably just say 6, though, wouldn't they? But what did Tiffany just say? She said plus or minus 6. Where's the minus? I don't see a minus in here. How in the world could that be a minus? Because remember,
negative 6 times negative 6.
That's right, because what do you do when you take the square root of something? You're finding what number times itself, right, is equal to 36. Well, let's think about it. 6 times 6 is 36, correct? So that works, but there's something else. We just discussed it. What is it? Negative 6 times what? Negative 6 times itself. Negative 6 times itself is also equal to positive 36. So when I take the square root of 36, you actually get two values. You don't get one. Normally in everyday, math or whatever, I guess, if I just asked you the square root of 36, you would say 6. I don't know when you first learned this. You probably learned this in middle school somewhere, maybe even in elementary. I don't know when they first did square roots. But normally when you're a little kid, when you first learn square roots, they would say, what number times itself is 36? And people would say, okay, no, 5 isn't, right? Because 5 times 5 is 25. What about 6? 6 times 6 is 36. Oh, yeah, 6, right? And they stop right there, usually little kids, because they really haven't dealt with negative numbers and that kind of stuff. But then you start getting into algebra, you start learning about negative numbers, and you're like, hey, wait a minute. It's not just 6, it's 6 and it's also negative 6. But how do we write this? You could say 6 and negative 6. You could do that, but that's a little too much to write. So instead of writing it like that, some people do this, put a comma and put a negative 6. That's still too much to write. So here's another way. Tiffany already said it. What'd she say? Plus or minus 6. Do you see that? This gives two answers in one nice little neat way to write it. There's a plus, a positive 6, and a negative 6. So the square root of 36 is positive 6, and it's negative 6. You right with that? Okay. What about this? What if we had the square root of negative 25? What would that be? Actually, forget that for right now. Let me think about that for a second. No, yeah, we can do that. That's fine. It's perfectly fine. I don't know what I was thinking. What about this? What do we do with the negative when it's inside of a square root? Becomes a what? Becomes an I. That's right. It becomes an I. So it goes out of the square root, becomes an I. But now I got the square root of 25. What's the square root of 25? Is it just 5? Right. Before, when I had you write down the answer, I didn't have you write down the plus or minus, did I? But now talking about this quadratic stuff, now it's going to be important that you realize that you want all the possible answers. So it's a positive 5i and it's also a negative 5i. Everybody see it? So when you have a square root, from now on, we're going to put that plus or minus out in front of it. Make sense? So make sure you put that plus or minus there. Don't forget. All right. Let's get into, it's not much harder, but let's do this. What we're going to do is we're actually going to solve for x. We're going to find what x is equal to. So here's an example. Or solve for whatever letter they give you. Right? What if I did this? This is kind of the same thing that I just wrote. It says x squared equals 49, and I have to solve for x. Problem will say solve. Right? The only thing to solve for is x, so we solve for x. What do you think? Well, what's it really saying? It's saying what number, if I square it, I'm going to get 49. You could probably do that in your head, couldn't you? 7, right. 7 squared is 49. Is that the only answer? What else? Negative 7 as well, right? Because if I take negative 7 and I square it, right, multiply it by itself, negative 7 times negative 7 is also positive 49. So I have two answers for this, don't I? But let me show you a little process, a little algebra to get to this. I want to get x by itself, so I have to get rid of that squared. How in the world do I get rid of a square? Say it. Square root it. That's right. I take the square root because the square root undoes, right, or it cancels out that squared right there. Does that make sense? Right? For instance, if I had like 3x equals 12, how do I get rid of the 3? I do the, what? What's the word I always use? I always do the what? The opposite. I always do the opposite. What's the opposite of division? Or sorry, I give it away. What's the opposite of multiplication? It's division. So I divide by 3 on both sides, right? What if I had this? What if I had x divided by 5 equals 2? What is that 5 doing to the x? It's being what? Divided. So I have to do the opposite to get rid of it. So how do I get rid of it? I multiply by 5. Okay? I do the opposite. What's the opposite of squaring something? Taking the, no, not dividing. We said right here the opposite of multiplication was division. If I square something, what's the opposite of squaring? You look on your calculator, it gives you a big hint. It probably gives you a square button on your calculator, then a second function, some calculators, second function squared gives you what? The square what? Square root. That's right. So what's the inverse? What's the opposite of squaring something? Come on, talk to me. Square root it. Okay, you got to square root it. So the opposite of squaring something is taking the square root. So if I take the square root of one side, what do I have to do to the other side? Whatever you do to one side, you got to do the other side, right? So if I take the square root of the left side, I have to do what? Take the square root of the right side. But remember what we're doing, though. We're not just putting a square root. What are we putting in front of that square root? Come on, guys. Right? We did it right here. We did it twice, didn't we? Did it twice. Right there and right there. We spent all that time talking about it. So if I take the square root, right, of both sides, what am I going to do here? I'm going to take plus or minus. Okay? Make sure it's plus or minus. Now we can do this. So what is the square? What's plus or minus the square root of 49? It's just plus or minus 7. All right? So that's how you would do that. What if you had something like this? What if you had x squared equals 5? and I ask you to solve for x. Okay, this problem would say solve for x. Well, you got the squared here. How do you get rid of a squared? Take the square root, okay? And then you take the square root of the other side. What do you always put in front of that square root now? Plus or minus. So that's your answer right there. X equals plus or minus the square root of 5. Make sense? Pretty easy, isn't it? Yeah, I think so. What if you had this? What if you had x squared is equal to negative 17? If you look at this, before we did that imaginary number stuff, you'd look at this and you say, well, there's nothing if I square it is going to give you negative 17. Think about it. Is there any real number? If I squared it, would I get a negative anything? No, because when I square something, I'm always doing what? Multiplying it by itself. So there's nothing, no real number. If I multiply it by itself, am I going to get a negative? Two negatives multiply to be a positive, right? Two positives multiply to be a positive. There's no way I could take the same two real numbers, multiply them together to get a negative anything. So my answer is not going to be a real number. But we don't just deal with the real numbers anymore, do we? We just learned, you just took a quiz on it, on imaginary numbers. So that's what we're going to do. Watch what we do. We take the square root of this, we take the square root of this, put a plus or minus in front of it. We don't leave it like that, though, do we? It's supposed to be plus or minus. Looks a little weird. So this is x, right? Because the square root cancels out the squared right here. Put plus or minus. Now what happens here? We don't leave it like that because we don't want that negative inside of there. That becomes a what? Yeah? Well, not just 17i, because the 17 is still under the square root. So it's the square root of 17i. But a lot of times we'll put the I out in front, just so it doesn't look like the i's inside the square root. Okay? It's not so hard, is it? It's not that hard at all. All right? Remember, this is what we did on the quiz, right? You just took a quiz on this stuff. So we take the negative inside the square root, turns into an I. Make sure you put that plus or minus. That's really the big thing about today, is make sure you put that plus or minus in front of it. I can almost guarantee, and I hate to say this, and I hope I'm wrong, I really do, but I almost guarantee on a quiz or a test, people are going to forget to put that plus or minus. Count up, rewind the video, count up how many times I've told you to put that plus or minus out in front of it. All right, and I can almost guarantee somebody's going to forget to do that. You've got to practice it. You do it over and over and over again, then you won't forget it. It's those who don't practice it that really don't put their 100% effort into the worksheets and the homeworks that are going to forget that kind of stuff. So put 100% into it. Always put that plus or minus in front of it, and you'll be good to go. All right? Let's do another one. What if I had this? This is a little bit different looking. Just make it like that. Look at that. It's a little different problem. Let's make it a different color. Got to solve for x, right? That's what all these problems tell us to do. They say to solve for x. We've got to get x by itself. Well, what do I want to get rid of here? The exponent. Yeah, let's get rid of the exponent first, because this stuff inside the parentheses is being taken to the second power. I want to get rid of that second power. So how do I get rid of a squared? We've done this like 2 or 3 times already today. Do what? Square root it. That's right. Square root both sides. Now watch. I'm getting kind of tired of putting the square root on the left side, because you know what's going to happen, don't you? What's it going to do? It's just going to cancel out. So I'll let you do this, because you know by taking the square root it's going to cancel out. So I'm just going to cancel it out. Is that all right with you? If I do that, I don't have to put that big old square root on the left side. I mean, you know why it's canceling out, don't you? Because you're taking the square root. So if I took the square root to the left side, what am I going to have to do over here? Take the square root over here. But what do I put in front of that square root? Plus or minus. That's right. Now, I'm not finished, though, am I? Let's drop everything down, make it look nice and neat. That's it. Okay, so that's what I have so far, but I want to get x by itself. Now it's really simple. Now I just have to get rid of this minus 2. Jared, you with me? Come on, snap out of it. I got this x minus 2, and now how do I get rid of that minus 2? I add a 2, and I'll just put a plus 2 right here. This cancels out. X equals plus or minus square root of 17 plus 17. Why did I put 17? Yes, I did. Thank you. Did 17 on the other problem. I must have had 17 on the brain. All right, so you're absolutely right. There we go. It's 7, not 17. And then plus 2. And there it is. Now, you could write it like this, or if you wanted to, some people put that, that constant, they put it out in front. To tell you the truth, most of the time, that you'll see your answers, they probably put that constant out in front to put the square root of 7 on the right. But either one is fine. That's perfectly fine. There's no problem with that. As long as there's a plus or minus in front of that square root of 7, then you're good to go. Or you could write it like this. This is probably a little bit more, I don't want to say acceptable because they're both acceptable. It's a little more common way to write the answer. Okay? So either way you write it, it's perfectly fine. I believe if I read off the answers, I'll probably read it off like this. I'll probably put the constant first and the square root at the end. I think that's how they write it. So what do you think? It's not so hard, is it? We got time. Let's do another one. Let me find a good one. Alright, here we go. Here's a nice one. I'll let you try this. We got a few minutes here. And I'll let you try this one on your own. Let's go with orange. So here it goes. It says solve. So it's 5x minus 3 squared equals negative 3. So this thing will test several different things that we've talked about today. All right? So write it down and try it. Solve it. Try to get x by itself. All right, time's up. Let's see what you did. All right, first thing. Wendell, what'd you do first thing? What was your very first step? Get rid of the square. Good. Okay. So and how do you do that? How do you get rid of the square? Square root both sides. Right. I know I'm going to square root, but I don't need to see that big old square root there, do I? So I'm just going to get rid of it. But what do I do? What do I have to do to the right side? Square root. What do I put in front of that square root? Plus or minus. Good. Okay. So let's bring everything down. 5x minus 3 equals. Let's clean this up a little bit. How would I write this? Yeah, I square root of 3. Okay, because that negative came out, became an I, got the plus or minus in front of it, you're good to go. And really, just got to do a couple things here now, don't we? All right, Jared, what do we do next? Okay, add a 3 to both sides. So I'll add a 3 over here. Or we could put it out front, couldn't we? So it's 5x minus, oops, I already got rid of the 3, didn't I? There we go. So 5x equals, you want to put the 3 out in front of this instead of behind it. So plus or minus, and then I square root of 3. Okay, good. All right. Arturo, help me out. What am I going to do now? I've got to get x by itself. So what do I have to get rid of if I want x by itself? What's right next to the x? Okay, how do I get rid of it? If it's being multiplied, how do I get rid of it? Divide it. Good. So I divide by 5. Now, you could probably put the whole thing over 5, and that would be okay. I don't have the answer in front of me. I think they let you do that. So let's just do it like that. So put this all over 5, and that's your answer right there. What's another way you could write it, though? You could split it up, couldn't you? 3 over 5. Plus or minus, and then I guess put the I there, right, since you have a square root, and then square root of 3 over 5. And that would be okay, or you could take this I and put it over here, right, if you wanted to do it like that. That's probably the best way to write it like that. What if you had something like this? Now, let's say that was instead of 5, let's say that was a 6. Would you just be able to leave your answer like this? No. Okay, when you have a situation like this, when things will cancel out, right, and simplify, you definitely need to. So it's always a good idea to think about writing it like this, because with that 5, it was perfectly fine the way it was, but with a 6, look what's going to happen. This will simplify, won't it? So my final, now this won't simplify, nothing will happen there, because that's a square root, okay, of 3, but this will. So what is it? It's 1/2 plus or minus square root of 3 over 6 I. Everybody see that? So that would be the way to write it, not like this. If that was a 5, or if that was a 6 and not a 5. Got it? So it's good to think about breaking it up, because sometimes it will simplify a little bit more, and you need to simplify it as far as it'll go. Well, that was a good start, wasn't it? Now, we just scratched, or we just hit the tip of the iceberg, as they say, all right? Scratch the surface, whatever metaphor you want to use, okay? We just barely got started on this. we're going to hit it a little bit deeper tomorrow. But that's a good start. I'm not even going to give you homework tonight. You took the quiz today, so that's good enough. Okay? So we'll finish it tomorrow, and then I'll give you a worksheet tomorrow to work on.